evening, and we're just about ready to close out our inspection of Aquarius and get back for a pleasant evening at Odyssey. Good night.
13, we've got one more item for you when you get a chance. We'd like you to stir up your cryo tanks.
Okay, stand by.
Guys, look at your O2 quantities and see if you see a big change.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
When Apollo 13 had the explosion, it wasn't long after that actually happened that Parker Hannifin was contacted, because they figured out that one of the oxygen tanks on the Apollo vehicle blew up. They lost half the oxygen. They might have a problem with having enough oxygen supply to get back to Earth. And part of the analysis of that was by asking Parker to help them figure out, with the components that we provided, how do we maximize that oxygen capacity. But it's interesting from the standpoint that the Apollo vehicle had a filter to take this carbon dioxide out of the air. And the lunar module had a similar filter, but it was a smaller size. And when the accident happened on Apollo 13, then they discovered that, well, the filter from the Apollo system wouldn't fit in the LEM system, but they already had made the decision to use the lunar module as the vehicle to go back to Earth in. So all of the environmental stuff had to be jury-rigged so that it could be done from the lunar module side. And that meant that they had to take filter assemblies from the Apollo and put them into the lunar module system with duct tape and stuff. So one of the things they wanted to do was to evaluate the thing called the oxygen control assembly, which is a component that we built for Apollo, and just determine whether it was going to be able to work satisfactorily in these conditions that it was never tested for. So that's what the remote test site facility was used for, because we wanted to test it with oxygen. You can't do that in the standard laboratory environment here in this facility. So we put the team together. I think there was about 10 people that went out to this test facility, mostly technicians, that built the facility that needed a requirement to make that valve do what it had to do. We provided the data back to the people in the office, and through some magic, we got an answer to NASA that they were looking for. That probably was the key to the whole trip that made that success, that vehicle a success coming back home. I can't imagine it was going to happen, but it did. The regulator was designed to reduce 3,000 psi oxygen down to 1,000 psi to fill the backpacks that the astronauts use to go onto the moon. So that's its main function. But as part of the trip that was required to come back to Earth, we had to use all the oxygen, all the way down from 3,000 psi down to as low as it could go. And they wanted to know that when they reduced these flow rates, whether our regulator was going to not do something strange and not allow that to happen. I mean, you think about how a regulator works, and it should have been fine, because you're just reducing the flow rate. You might not have as good a control, but it does work properly. And we proved through testing that it could be done, and in fact, obviously it was done. From my standpoint, I didn't realize the complexity of what we were trying to do, or the implications of what we were trying to do, until it was almost all over, and we said, wow, we really can participate into something that is a life-saving situation. And it didn't hit home until we actually got done with our test program, for me anyway.
But these tests were run over and over again. In the beginning, it didn't appear that we could actually have enough oxygen left to allow the astronauts not only to live, but you also need it for electricity and power and temperature and all that stuff. So it was important that we could dissipate this oxygen at 1,000 psi regulator down to a few psi, and that's not always easy to do that. And so we had to run test after test after test to verify that we could do it. And many of the tests failed. They said, we can't do it, we can't do it. So the guys kept working and working and working, and finally got to the point where they could actually have enough oxygen left to survive. So our part was very critical to the survival of this mission. And so we should be very proud of that accomplishment.
In those days, the telephone was critical. Even within the facility, everything was done by telephone. You didn't have portable devices to deal with. You used the telephone.
Not just the technicians, but the engineers, design engineers, and analytical engineers, running all kinds of analysis to make sure it worked, and then to verify it in the lab. So it was a very comprehensive effort by a whole team of people. Over a 2-day period we're talking about. And not only our stuff, there were other developers and contractors who were doing the similar thing. It was an effort to make sure they got home.
We did work around the clock, but it was only 2 days. So everybody was just so keyed up and doing everything they could possibly do to help get this answer that we wanted. I don't think anybody realized that they weren't sleeping very much for those 2 days. They were just so intense on making this happen. And we did it.
When they finally returned, there was absolute hysteria almost, so overexcitement of how great it was, not only for them to come back, but to know that we played a critical role in it. So it was very, very important. And it wasn't shortly after that the astronauts visited our facilities to express their thanks for what we did too. And in those days, the astronauts were like the cowboys of the Wild West. I mean, they were heroes. And you take them on a tour through the shop, and you go to the machine shop, there'd be banners on the wall. Welcome Buzz, welcome Fred Hayes, in this particular case on 13. I mean, that was the atmosphere. And we were, of course, proud of what we did to make this happen successfully. At this time, Parker Aerospace was on Century Boulevard at LA Airport. We had 13 acres there. We wanted to expand. Marriott wanted a hotel. The Marriott Hotel Company and Parker went into agreement. We took our 13 acres, essentially leveled the buildings. Marriott bought 75 acres for us in Irvine, built 4 or 5 buildings, and we flip-flopped property for a tax benefit. So we had a number of astronaut visits before, after, Werner von Braun was here. So there's all kinds of stuff in the past. So a lot of interaction between the head NASA people and astronauts were here.
They just were very appreciative about what we had done for them. And I was so starstruck, I don't think I know that I said anything. I just was listening to what they had to say. But I don't think that it really sunk in as to what we had done until the papers came out and you got to read articles about what had happened. And, oh, you were involved in that. Oh, you did that. Oh, that's pretty cool.